Should I read the word problem too?
Yeah, I don't mind just reading it. Just center it a little bit.
All right. Kind of. All right. So number 21. On Friday, you left for a weekend camping trip with 110 miles on the odometer and 14.5 gallons of gas in the tank of your car. When you returned on Sunday, the odometer read 299 miles and you still had 7.5 gallons of gas left. What was the fuel efficiency of your car on this trip? So, what I did was I wrote down I wrote down the number of miles that was on the car in the first place, and then how many gallons of gas were in the tank. So as you see, I wrote down 110 miles, 14.5 gallons of gas. And then, after the trip, you had 299 miles and 7.5 gallons of gas left. So I wrote down those two numbers as well. And then what I did was I subtracted 299 minus 110 miles to get 189 miles traveled during that trip, and then I did the same thing with gas, so 14.5 minus 7.5 was 7 gallons used up. And then to find out miles per gallon, since it's miles over top of gallons, you would do 187 miles divided by 7 gallons, and then you would get 26.7 miles per gallon, or just round up and get 27.
Yeah, I think you just pulled down. I don't know even why. It actually comes out nicely. For some reason, you have 189 here, and then you pulled it to be 187.
I do.
So if you make that a 9, it does come out nicely to be 27. So just make that into a 9, and then it actually comes out nicely. There you go. And then you do get the 27 miles per gallon. Any questions with that one? It's okay. Oh, keep it there.
Oh, keep it there?
Keep it there.
My bad.
It's like so quick on the.
I tried.
If some of you ended up getting a negative answer because you used the slope formula and you didn't take the original gallon minus the new amount, or the original miles minus the new amount, you might have ended up with like a negative number. Why would you end up with a negative number in your answer? Because I'm walking around and seeing some of you have a negative. So why would it be negative? If you have a negative 27, why would you get a negative for this? Dylan? Yeah. If you're losing gas, so if you set this up, because I started with 299, and some people may have set it up like slightly opposite and taken 110 minus 299, you end up with a negative 27 because you're losing gas. So if you get that negative, it's okay. Don't keep the negative in the answer though. Kind of transform it into what it means with the word problem. So it's 27 miles a gallon, and that was the fuel efficiency for your trip. Any questions? So if you got a negative in the answer, it's okay, but just know that that negative is there only to say, hey, you're losing that as you drive. All right, so Nina has the second one.
Okay. So when you started your shift at 7 a.m., 120 steel valves had already been machined and were ready for assembly. At 3 p.m., your shift ended and 424 steel valves were now completed and ready for assembly. The target production rate is 36 steel valves per hour. What was the production rate for your shift? Would your supervisor be satisfied with the work pace? Okay. So first, I figured out how many hours the shift was. So between 7 a.m. and 3 p.m., that's an 8-hour shift. And then there was already 120 valves made, and then you needed to have 424 total. So I put it in the slope formula. So 8 was the slope, and then 8x plus 120 equals 424 because you already had 120 and you need to have, and then you need to do between 8 hours. So then I just solved for X, and I got 38 valves per hour, and your supervisor will be satisfied because you were ahead of production.
That was a really nice way of doing that problem. You can keep it up.
Okay.
So Nina did this one, I think, differently than some of you worked through the problem. So she treated the time of 8 hours as the slope. The 120 was what you started with. So this was your initial value. So she said 8 is the slope times the x. The 120 is what we started with. So x would be like how many I need to make per hour. And then that's equal to what we're projected to make, or the end result, the 424. So she actually created it into an equation, which is good. You can definitely set up an equation. Is there a different way that we could set up the problem and still figure out if we met these supervisors' restrictions of producing at least 36 valves per hour? So how else could we set up the problem? Josh?
You could do the equation to find the slope y2 minus y1 over x2 minus x1, and make the number of valves in the hours between x and y.
And which one did you make, x?
I made 7 and 3.
Yep. The x's. So okay, so we have time for the x's, and then at 7 a.m. there were 120. At 3 p.m. there were 424. So you could make them into ordered pairs and think of them as having an x and a y, and then plug them into the equation for slope. So if you plug them into the equation for slope, you ended with 424. You began with 120. The only problem is when you take those numbers and you put them in the denominator. If I take 3 and subtract 7, this is time. They're actually not the numbers 3 and 7 because it's the hour of 7 a.m. and then it's flipped into the afternoon of 3 p.m. In the denominator, you want to account for the amount of time that you worked. How much time has passed? So if you started at 7 a.m. and you worked till 3, how long was your work day? Brandon? 8 hours. So if you put 3 minus 7 down here, you're going to get a negative 4, which isn't the correct solution. You can't have a negative 4 down there because that isn't showing the amount of time that you worked.
I did 15 minus 7. because
Yes. Why did you say 15?
3 p.m. is 15 hours past 4 a.m.
So if you think of the military time starts with your first hour and it works through till you get to your 24th hour. It doesn't convert to the PM time. So 7 a.m. is my 7th hour of the day. 3 p.m. is my 15th hour of the day. So you could use 15 minus 7 and then you get 8. You could have also said 7 a.m. was my start time of 0 and 3 p.m. was my finish time of 8 hours. However you thought about that, just know that if you got a negative 4 in the denominator, you didn't work negative 4 hours. You actually worked 8 hours. So when you're dealing with time, sometimes you can't just subtract time, especially if you're going from a.m. and then p.m. in the afternoon. Any questions? So either way, you're going to get 38 valves per hour. And then yes, it does meet the supervisor's qualifications of getting the 36, at least 36. Questions on that? So Nina and Luke, thank you for being the first 2 guinea pigs today. I appreciate it. They both did a good job. And was it that hard? No. Not too hard standing up here. Excellent. So tomorrow I've got 3 different problems up there, and I'll ask about those in a minute to see if we can get some other people to volunteer. So if you could, I'm not going to collect this, I walked around. So if you could put this back in your folder and take out page 11 from your notes packet. Really easy short notes today. We're talking about graphing. So we're gonna graph equations of lines in slope-intercept form and in standard form, just reviewing them. Literally, it's a review. We're gonna do one of each and then we're done. Really pretty straightforward. But we're gonna talk about a couple of key terms. And the first one is a parent function. Functions actually are like families. So when we talk about the 8 or 9 different functions we go over, the parent function is the most basic type of equation or function in that family, and then as you add numbers to them and put variables in front or numbers in front of the variables, they get a little more involved. So a parent function is just the most basic form of a function. And I'm going to say family because each function, each type of function is really considered a family. So the linear function or the line is a family of functions. When we look at parabolas, the u, that's a family of functions. So the most basic form is considered the parent form. So that means there aren't any numbers added to the variable. There isn't a number in front of the variable. It's just really basic. So for a line, y equals x is the parent function for the line because there isn't a y-intercept, a number being added in front here. There's not a number in front of x to change the steepness or the slope. So this is considered the parent function, pretty basic. If I had y equals x squared, that's considered the parent function for a parabola. So pretty much you have a y and an x and some kind of power or something happening with the x, but that's it. There's some numbers to move the graph or change what the graph would look like. So the graph of y equals x is shown here. I could really write this in slope-intercept form as 1x plus 0. Because slope-intercept form is y equals mx plus b. This 0 correlates with the y-intercept at y equals 0, which is at the origin. So the y-intercept is where the graph crosses the y-axis, which in this case, if it's just y equals x, it's at the origin. The slope is the number in front of x, and the slope is 1 if there's not a number written there, which means I'm supposed to rise 1 and run 1 to get to another point on the line. And I could do that a bunch of times to find a new point on the line. So, parent function, just a line, goes through the origin, y equals x, my slope is just a 1 every time. Underneath that it says, in general, a y-intercept of a graph, and I'm going to abbreviate that as y-int, is the y-coordinate of a point where the graph intersects with the y-axis. So if you're asked for a definition of a y-intercept, the easiest thing to say is wherever the graph crosses the y-axis. Not your y-intercept. So where it intersects with the y-axis is a y-intercept. We're going to talk about slope-intercept form first, and then we'll talk about standard form on the next page. But we know slope-intercept form is y equals mx plus b. I think we've looked at slope-intercept form almost every day in some way. Remember the m represents your slope, which we said was rise over run. We said that yesterday. But slope is the movement of the line, or the change of your line. How does it move up? How does it move down? So slope is movement. So how steep is the line going to be? The b value, that's the y-intercept. We're going to write it as an ordered pair because it's a point on the graph. And a point on the graph is an x and a y. So we'll be writing it as 0 because the y value is b. 0 for x because it's crossing the y-axis somewhere. You always begin with the b value. That's where you start plotting points when you're in y equals mx plus b form. So you begin with b, you move with the slope. So just filling in the blanks over here, if I'm graphing in slope-intercept form, the first thing that you need to do is to make sure your equation is in slope-intercept form. So that's step 1. Write the equation in, you could say slope-intercept, or you could say y equals mx plus b form by solving for y. So if you don't already have y by itself and you're asked to graph in slope-intercept form, you have to get y by itself. So rearrange your problem, take the number to the other side, divide by whatever's in front of x, or I'm sorry, y. The second thing, we want to find the y-intercept, which is b, and use it to plot the point 0, comma b. It's going to be pretty easy to find once it's in y equals mx plus b form. And again, b is where the line crosses the y-axis. The third step, identify the slope, which is m, and use it to plot a second point or a third point. We'll generally graph 3, so they've got enough to make a nice line, but 2 is plenty. You only need to do 2. But I like to have a couple extra on there. And then the last thing, draw a line through the 2 points or through your multiple points that you have drawn. So get it in y equals, identify your b, find the slope, plot your points, draw a line. Pretty easy, straightforward. So at the top of the page, on the back, is y equals negative 3 halves x plus 1. So Dylan R, what's the slope? Negative 3 halves, and the b value is 1. Which really means I have the ordered pair of 0, comma 1. So Libby, how could you explain to a 6th grader how I graph this?
Since your y-intercept is 1, you want to plot that on the graph.
So here's the y-axis, we're going to plot that on the graph, right there's my 1. And then what do you do?
I do the run first.
Okay.
So you go over to.
So this bottom number tells you how far left or right you have to go. It's positive, so we need to go over to the right too.
And then since it's negative, you go down.
Right. The top number tells you if you're moving up or down. It's negative, so we're moving down 3. So however you look at it, she said she does her run first, so she would move right 2 and then down 3, or you could go down 3 and then right 2. Is 3 over negative 2 the same slope? Would it be a point on my line? Yes? These guys are the same, negative 3 over positive 2 or positive 3 over negative 2. If it's positive 3 on the top, then I will move up. If it's negative 2 on the bottom, you'd move to the left. So I could go up 3 and to the left 2 and still get another point for my line. As long as there's one negative in the problem, it's still a negative number. So negative 3 over 2 or 3 over negative 2, it's the same number. It's when you put 2 negatives in the problem that actually creates a positive and it won't be the same value. Questions? So if you flip the negative, the location of it, it just gets you the other side of the line. It just gets you the left side of the line instead of the right side. All right, so graphing a line, y equals mx plus b. Pretty straightforward. Let's look at the other form, which is standard form. We have both forms because it really does kind of depend on how you're given the problem based off of how you want to graph it. So if we have standard form, does anybody remember from the first 2 days of school what standard form looks like?
With X and Y on the same side.
Yeah, x and y are on the same side. The number on the other side is usually by itself for it to be in standard form. So ax plus by equals c is considered standard form. A, b, and c are constants. That just means they're numbers. They're not variables. So don't look up here and be like, well, we've got 5 variables here. No, they're not 5 variables. X and y are your variables. A, b, and c are just numbers. So that's standard form. When x and y are on one side, a number is by itself on the other. The last term here is x-intercept. So what's an x-intercept? Thinking about what a y-intercept is, what does that mean an x-intercept would be? Audrey, what's an x-intercept?
It's where the line meets on the x-axis.
Yeah. So wherever your line crosses through the x-axis, or whatever graph we have, that would be an x-intercept. So wherever the graph crosses the x-axis. So if it's crossing the x-axis, that means I'm going to have a number for x, but a 0 for y. Because now we're on the x-axis, we're not moving up and down, we're just moving left or right to get to a point. Graphing in standard form is probably the one that isn't used as much, because everybody prefers to solve for y and use slope-intercept form. However, if you're given an equation that looks like ax plus by equals c, why do the extra work to get it in slope-intercept form when it's pretty easy to graph in standard form as well? So the couple of steps here, it says write the equation in standard form if needed. If it's not in standard form, don't use standard form, use y-intercept form. So look at the way your problem is given and then decide how you want to graph it. So really, we're not going to worry about writing it in standard form, because if it isn't in standard form, you're not going to graph it in standard form. The second one, identify the x-intercept by letting y equal 0. So if I'm finding an x-intercept, my y has to be 0, because I'm trying to find x. And solve for x. Use the intercept to plot the point where the line crosses the x-axis. So if I'm finding an x-intercept, I'm going to be plotting a point on the x-axis. Step 3 says identify the y-intercept by letting x equal 0, because we want to find y. That means x has to be 0 if it's on the y-intercept. And solve for y. Use the intercept to plot the point where the line crosses the y-axis. So pretty much we're finding a point on the x-axis, a point on the y-axis. We're not finding slope. We're connecting those 2 points and we have a line. So draw the line through the 2 points. This equation, 2x plus 3y equals 12, is in standard form. So if it's in standard form, I might as well try and solve it or graph it using standard form. To graph it in standard form, instead of getting y by itself and finding the slope, we're going to just find the intercepts. And it's pretty easy to get the intercept. An x-intercept is found by letting y equal 0. A y-intercept is found by letting x equal 0. So if I find an x-intercept in my equation, I need to keep the x, because that's what I'm solving for. You're plugging a 0 in for y. So Julia, what happens when you take 3 times 0?
0.
It goes away. It's 0. So I don't have that part. So now I have 2x equals 12, which means x is 6. I have a point at 6, 0. Try and get used to writing it as a point. X equals is a solution to an equation. 6, 0 is a point that I plot on the graph. So without really doing any work at all, I know an x-intercept just by plugging a 0 in for y. Looking at the y-intercept, if I take that same equation, but now make x 0, so essentially I'm keeping the y, the x goes away. Julia, y is 4, or I have a point at 0, 4. So you could solve for y, get it equal, or into y equals mx plus b form, or you can plug a 0 in for x, plug a 0 in for y, use those 2 values as your intercepts, and then graph them. So at 6, 0, I have a point, and at 0, 4. You don't need to know the slope to graph a line. You just need 2 points that are on that line to get a line. Any questions? So we have slope-intercept form, standard form. It pretty much depends on how the equation you're given is initially, and then how you want to use, like which method you want to use. The last problems deal with horizontal and vertical lines. So you no longer have y equals mx plus b. You either have a y equals equation, and it's a horizontal line. So then I would want to plot a point that goes through the line 0, c. So if my equation is in y equals, yesterday Nina said that makes a horizon, the horizontal line, you have a slope of 0. It's going through one point, and whatever that point is correlates with your y equals equation. If it's a vertical line, it's x equals. So horizontal is y equals, vertical is x equals. And that's going to go through the point C comma 0. Because now I know my x value, I don't have a y value. Because it's just an x equals. So 2 last problems down here. Graph the horizontal and vertical line. The first one says y equals -1. This number here really is the point that my line goes through, and it's only one point. So I have a point at 0, -1. At that point, I'm making a horizontal line. It's just y equals, and it's always y equals -1. Make sure yours goes through -1. There we go. So this is just saying y is always -1. It's never going to change. So it shouldn't go up and down because then y would have a different value. The last one here, x is equal to 2. That means I have a point at 2, 0. So plot your point at 2, 0. X is only 2, so it cannot change left and right because then x would have a different value. So it just goes up and down. X is always 2. Questions? Hopefully pretty straightforward. So I'm going to pass out your homework.